Hello friends. Now let us take another example of this curve tracing. Here, first of all, I just want to mention a note. The note is like this. See, suppose in your curve, suppose curve is symmetric about a line. Now that line can be an axis, x-axis, y-axis, or any other line. Y equal to x, y equal to minus x, etc. So suppose the curve is symmetric about a line and it intersects the same line twice. So at 2 points it intersects the same line. Then definitely there will be a loop, okay, symmetric about the line within those points. Then there will be a loop-like structure. There will be a loop between those points. Okay. Now, for example, the loop can be like this. Suppose a curve is symmetric to x-axis, and suppose a curve is symmetric to x-axis, and it intersects x-axis. Suppose at this point, say A, and at this point, say B. Okay. Definitely within these 2 points, the nature of the curve is like this. Is like this. Okay. So this is a kind of a loop, right? So please take down this note. It says that a curve is symmetric about an axis or line and it is intersecting the same line 2 times. Okay, then there is a loop like structure. Okay, and we are going to use this note in this particular example. Okay, fine. So let's now see what is this example is. So I'll proceed with the same criteria. I'll start with first of all the symmetry. Okay. So see that here again the degree of y term is even, but degree of x term here is odd. Here also it is odd. Okay. So definitely the curve is symmetric about x-axis. So here since y replaced by minus y, okay, no change in the equation. No change in equation. Therefore, curve is symmetric about x-axis. Okay, curve is symmetric about x-axis. See that the degree of x is odd, x cubed here, and the degree of here x is also odd. So even if you change x by minus x, the equation is changing, but y by minus y, there is no change. Okay. Second, whether it passes through origin. Passing through origin. So we will put x equal to 0 and y equal to 0 in the given equation. So put x equal to 0, y equal to 0. Okay, and check whether the left hand side is same as the right hand side. So if we put that, this will be entirely 0 once you put x equal to 0 over here, right? And y equal to 0, the LHS is also 0. So therefore, equation of the curve passes through origin. Fine. Now, as soon as the curve is passing through origin, our first job is to find out the tangent at origin. So, third point, tangent at origin. Tangent at origin. and you know how to find out the tangent at origin. So you take the lowest degree term and equate it to 0. So let us find out what is the lowest degree term in this equation. So we need to take rewrite the equation once again. Okay, so let me rewrite the equation here. It is a plus x into y square equal to x square a minus x cube. Okay, if I open this, it is ay square plus xy square plus x cube plus x square a equal to 0. So minus, right? So what I can do is I can take this a common, or we can keep like this. Okay, fine. Now see that the lowest degree term is obviously this. This has degree 2. This has degree 3, degree 3. So let us equate this term to 0. Therefore, ay square. Okay, so if I take a into, this is y square minus x square equal to 0. So a cannot be 0, it's a positive constant, it is given in the problem itself. So y square minus x square equal to 0, and therefore y minus x and y plus x equal to 0. So this gives me the equation of two tangents. Therefore tangents are y equal to x and y equal to minus x. So these two lines are the tangents to the curve at origin. Okay, remember this. We have calculated. Okay, here we have equated the lowest degree term to 0. This is by Newton's method, and we have got the equation of tangent at origin. Remember. Okay, fine. Now since that the curve is symmetric about x-axis, right? Symmetric about x-axis, so it must intersect x-axis somewhere. So let us find out where this curve intersects x-axis. Okay. So next to find out, so fourth point, to find intersection with x-axis. To find intersection with x-axis. Okay. So that is possible if I put the equation of x-axis in the given equation of curve. And equation of x-axis, you know, it is y equal to 0. So I'll say put y equal to 0. This is the equation of x-axis in given equation. In given equation of curve. Right? So if we put y equal to 0 over here, what we will get is x square into a minus x equal to 0. So see now what we have obtained. We have obtained that x square equal to 0 and x equal to a if we equate this factor to 0. Okay. Now x square equal to 0 gives me two values. Actually, this implies what? X is equal to 0. Okay. And this implies x is equal to a. So actually there are 2 points on the x-axis where the curve intersects x-axis. How to get those 2 points? So if I put x equal to 0 in this equation of the curve, what I'll get y as? Y as 0. So for x equal to 0, y will be 0. Okay, from 1. If we call this equation to be 1. And if we put x equal to a there, see what we'll get. X equal to a. So this is 2a. But this is 0. Right? A minus a. So y will be 0. Again y is 0. So 2 points we have obtained. 0, 0 and a, 0. Okay. Okay, now see that I have just mentioned the note that the curve is symmetric about x-axis, and now it intersects x-axis at two different points. Definitely within these 2 points there will be a loop like structure. Okay, so we will note this and we will draw when we will finalize our analysis. Okay, fine. So now let's proceed further. Now we will find out the asymptotes of this. Uh, so fifth point is asymptote. Now see that the curve is symmetric about x-axis. So the asymptote must be parallel to y-axis. How to get those? Then, so the asymptote is parallel to y-axis. So what you do is you take the highest. So the rule is like this. Equate to 0 the coefficient of highest degree term in y. So equate to 0 the coefficient of highest degree term in y. Now look at the equation. We can write the equation as a plus x times y square is equal to x square into a minus x. Right? So the coefficient of highest degree term in y is a plus x. If we equate it to 0, so a plus x equal to 0. So x equal to minus a. So x equal to minus a, this is a line parallel to y-axis, okay, cutting the x-axis at minus a is the asymptote. So beyond this line, there will be no part of curve exist. Fine? Okay. So now this itself gives me the somewhat the idea of the curve. But before I proceed, we will look at the region of absence. So region of absence is that will be sixth point, region of absence. Okay, now see that here for which values of x you feel that y square will be negative. Y square will be negative. So definitely if x is greater than a, x is greater than a, see this term is always positive. This term is positive. Okay, because we are taking a to be positive and x is greater than a, so x will be, we are also taking positive. But look at this term, a minus x. So if x is greater than a minus x will be less than 0, right? And this implies y square is less than 0 and therefore y is imaginary. Okay, so this implies the curve not exist for x greater than a. Okay, so now we got the limit. Okay, and now we can draw all this information. So we will gather all this information one by one and we will try to draw the curve. So let me draw this curve now. And this drawing is also essential in the examination. Okay, so first let me draw the x-axis, the y-axis. Okay, now all these points, so this is origin, the curve is intersecting at a comma 0 as well, so a comma 0 is taken over here. We know that the curve is symmetric about x-axis and it intersects x-axis at 2 points. Definitely there will be a loop like structure, something like this. Okay, then after x equal to a, x greater than a, there will be no part of the curve. So after this line there will be no part of the curve. Okay, and these are the asymptotes, right? So asymptote is x equal to minus a. So this is the asymptote. This is asymptote. So asymptote means what? The curve is going like this and it goes parallel to this asymptote. Similarly to this side, the curve is growing like this and goes parallel to the asymptote. So this is a rough picture of this curve. Okay, I hope you have understood this. Just go through it once and try to solve some of the more exercises. Okay, thank you.